In this video, we want to talk about the concept of attributes in ProModel. So let's look at the barber shop example and see what do we mean by attributes. I want you guys to please open the barbershop model that we work on in week 2. So this was the model in which the customers came to the barbershop, they got to the waiting area, and then from there, the customers went to the barber, they got their haircut, and then they left the system. So let's assume in this scenario, we know the arrival rate for the customers. So I know what is the frequency of the customers that come to the system. However, when the customers come to the system, we are going to differentiate them. Some of the customers are men, some are women, and some are going to be children. And depending on the type of the customers, they are going to have different haircuts at the barber. Okay, so then the question is that, okay, if the customer is the only entity that comes to the system, how we are going to assign different processing time to the customers when they get to the barber? Attributes are the concepts that help us to implement this feature. So attributes are basically like a tag that we give to the entities. And these tags help us to differentiate entities from each other. So as I mentioned in the barber example, the only entity that I have in the system related to the entity customer. So that's the entity I have, and that's the entity that comes to the system. However, when that entity comes to the system, I may want to put it in different categories based on the characteristics that this entity has, and send different categories maybe to different routes, assign them different processing times, and even collect different statistics for different categories of the entities. And in the example of the barbershop that I mentioned to you, I may want to know, okay, how many men, women, or children have left the system? What is the time, the cycle time, or the time that they have spent in the system for each one of them? So if I just have one entity customer, I cannot collect these different statistics for different categories of entities. However, the concept of attributes help me to do that. I can give an attribute to the entities, for example, and I can call that attribute a customer type. And in that attribute, which every single entity who enters this simulation is going to get, in that attribute, in that tag, I'm going to specify if this entity is a man, or if it's a woman, or it's a children. And as this entity goes through the system, they carry this tag with them along the way. And by looking at the value of the tag that they carry, I can always treat that entity differently if I need to. Similar examples can be, for example, in the hotel industry. Imagine I know the arrival rate of the customers, how frequent the customers come to the system. But when the customers come to the system, depending on the type of the customers, for example, if some of the customers are VIP and some of them are regular, depending on the type of the customers, I may send them to different agents. We may process them differently. We may give them different priorities. And these are the things we can implement by just having one entity as the customer. And however, these entity is going to get a tag of customer type, for example, again. And in the value of this tag, I'm going to specify if that's a VIP customer or if that's a regular customer. And when that entity goes throughout the process in the simulation, based on the value of this tag that these entities carry, they are going to be treated differently. The same concept can exist for a manufacturing process. In the manufacturing process also, we may receive the jobs as the entities that should be processed. But then when the jobs come to the system, based on different probabilities, they may have different categories, and different categories of the job may go through the process or may go through the process differently, and may have different processing time. So the attributes are behaving like some tags that we assign to entities, and all the entities in the simulation model carry this tag with them. And by giving different values to these tags, or we can create different categories of entities, and we can treat each category differently if we need to. So in the barber example, let's assume that when the customers come to the system, 30% of them are men, 50% are women, and 20% are children. And depending on the type of the customer, if they are men, women, or children, they will have a different haircut time with the barber. Okay, so still the only entity that I have in the system is customer. I have the information related to arrival rate of the customer. So customer is the entity that has to come to the system and gets to the waiting area. However, when they come to the system, then I can put them in these categories based on these probabilities. And then each category is treated differently in the rest of the process. Assigning the attribute of customer type, for example, to this entity would enable me to differentiate different type of customers and treat them differently throughout the process and collect different statistics for them and so forth. Okay. So that's what we want to do, okay, to learn how to assign these tags. And I want you guys to pay attention that these tags are actually, each entity can carry different tags, as many tags as possible, okay? So these tags can differentiate different entities from each other. So now I want you guys to answer this question. If we assume, if I'm modeling Cal Poly Pomona, and if we assume the students are the entities in this system, so can you give me some of the tags that these students have that differentiate them from each other? And because of that, they may go through the process a little differently or experience different things.
Their major.
Their major definitely is one.
Full-time or part-time?
Yeah, if they are full-time or part-time.
They're standing.
They're standing.
Like if they're freshman, sophomore.
Yes, that's correct. What else?
Gender.
Their gender. And see, my point is that if I'm modeling Cal Poly Pomona, and the entities that enter the system are students, but each student, each entity, okay, attributes are associated with entities, but each entity is carrying these attributes, and then depending on the values of these attributes, then I may this entity may go through a different process or experience different things in the system. Okay, and and we want to learn how we can basically implement this concept of attributes in ProModel. Okay, so I want you guys to please open the Barber model that you had in the folder for week 2. Please go to the folder for week 2, open the Barber shop model, and then save it as a new model in the folder for week 6, right? So create a folder for week 6. And then inside that, save this model. But at the end of the name of the barber shop, I want you guys to put attributes. Okay, open the barbershop model in the folder for week 2. Save it as a new model in the folder for week 6. At the end of the name of the model, add attributes. Okay. Now, here, let's assume we wanna implement this scenario. When the customers come to the system, we wanna give them like a customer type attribute. And this customer type is going to be a man, women, or children. And then depending on the type that they have, they're going to have different processing time. At the end, when we are done with the simulation, I wanna be able to collect different statistics for the customers, if they are men, women, or children. Okay, and we'll get to that part. But for now, all I want now specify is that, okay, there are 3 types of customers, and each one of them has a different processing time. And so what I need to do is first define a tag. Entities still come to the system as a customer. So that's the only entity that I have. And in the arrival, customer is the one that comes and goes to the waiting area. And when I start the processing, customer is the one that gets to the waiting area, that is in the waiting area and wants to go to the barber. But right here, exactly right here, when the customer has arrived to the system, as soon as that happens, I want to be able to give this tag to the customers that tells the system that this customer that has come to the system and is going to go through the rest of the system is a man or woman or children. Okay, so I need to define a tag. So these tags are equivalent to attributes in simulation model. And here is where we can identify the attributes. For those of you who are using 2016 version, attributes you are in the build menu. If you open the build menu, you can see the attributes. So we go to the attributes. Here we can identify the attributes, as many as you want. You can define the attributes here. So I'm going to call this attribute customer type. You can call it anything. I'm going to call it customer type, okay? And then I press enter again here on the type. You can see that if you want to assign integer value or real values to these attributes. And I want you guys to pay attention that attributes get values. Yes, here my attributes want to show if they are men, women, or children, but I cannot write men, women, or children in the attribute. I have to assign numbers. So in my mind, I have to decide that, okay, I'm going to assign 1 for men, 2 for women, and 3 for children. Okay, so these are integer values, so the type of the attribute is going to be integer. Well, but if for some reason the attributes are going to get some real values, you can always identify real. Okay, so here I'm going to define one attribute customer type, and it's going to get integer values. And I have decided that I'm going to assign value of 1 for men, 2 for women, and 3 for children. Okay. So then here, I'm going to write everything here in the operation window, but I'm in the first line. As soon as the entity is in the waiting area, the customer is in the waiting area and wants to go through the rest of the system, right before that happens, I want to look at the customer and give them a tag of, and in the customer type tag that they already have, I want to put value of 1 or 2 or 3. So the tag is the same. The customer type is the tag, but the value that this tag is going to get for different customers is different. Okay, and I want to see how the simulation should know what should be the value of this tag for different customers. Okay, so this is the logic that I'm going to use. I'm going to generate a random number between 0 and 1, and then depending on the value of the random number, I'm going to give the corresponding tag to these entities. Okay, so first I want to create a random number between 0 and 1. So when I create this random number between 0 and 1, I have to save it somewhere, right? I can't just like have it on the fly. I have to save it somewhere and in a variable, and then you use that variable in a if then else condition to say, okay, if the value of this random number is in this range, then give the tag of 1. If it's in this range, give the tag of 2, otherwise tag of 3, right? So first I want to generate a random number between 0 and 1, and then I want to save this random number in a variable. For this variable that I'm going to use to save the value of this random number, I'm not going to define a global variable. I'm going to use what we call as a local variable. And I'm going to tell you in a second what is the difference. However, so let's first define a local variable. Like any modeling language, when you want to define a variable, what do? First, you define what is the type of variable. Is it integer? Is it a real number? Is it text or date or whatever? So here, the random number is between 0 and 1. So this variable that is going to save the value of this random number is a real number, is a real variable, right? So it's going to be a real variable. That's the type of this variable. Then you identify the name of the variable. So here, let's say I'm going to call this rand number. That's the name of the variable. You can give this variable any name that you want. I'm going to give the name of rand number. Okay. And then inside this, I'm going to save the random number between 0 and 1. And the function for identifying a random number between 0 and 1 is rand, R-A-N-D. And then in parentheses, you put 1. That will take care of everything. So rand, R-A-N-D, in parentheses 1, will generate a random number between 0 and 1. So the blue always is the keyword, right? So rand 1 generates a random number between 0 and 1. And then I say, put it in the rand number variable, local variable that I have defined. And here also I have mentioned that this local random number that I created is a real number. Sorry, this local variable, this local variable rand number that I created, this local variable is a real number because it just obviously saves values between 0 and 1. So it's a real number. Okay.
And what values between 0 and what?
Between 0 and 1.
Thank you.
So that's what this rand1 means. Rand1 means generate random numbers between 0 and 1, continuous random numbers between 0 and 1. Okay, and save. And then when I say rand number equals to this, that means whatever comes out of this rand function, whatever is coming out of this, then save it in the rand number variable, local variable that I have defined. And the type of this local variable is a real. It's a real number. Okay. And then what do we do next? Okay, so what is the difference between this local variable and this global variable? So when we use this variable in the menu to define a variable, these are global variables. What is a global variable? A global variable is a variable that you can define anywhere in the simulation, in any line, and you can change it anywhere. Okay, so for example, for the working process, when we define it as a global variable, I increase it in the first line and I decrease it in the last line, right? You can use it, you can change it anywhere in the simulation model. However, for the local variables, as their names show, they're local. You can define them and you can use them only in the place where you have defined them. So I defined this local random number here. I can use it only here in this operation window. If I go here in the logic, for example, window, we don't know that variable. If I come to the next line, we don't know that variable. If I call that variable and I say, oh, increase, add 1 to it or what, anything, I'm going to get an error. Anywhere else in the simulation model that I go, I don't know that variable. That variable is unknown. This variable, this local random variable, is known only at the place where you define it, and that's the only place that you can use it. Okay, so I call this a local random variable, and for any variable that we define using the variable option in the menu, we have global random variables. Okay, so first, I defined a random variable, okay? Now I wanna look at the value of this random variable, and I wanna say that, okay, if the value of this random number is in the first 30% is less than or equal to 0.3, then do what? What should happen here? So if the random number is less than or equal to 0.3, so here, we have generated a random number between 0 and 1, right? I say, okay, if the random number is in the first 30%, okay, which happens only 30% of the time. So that takes care of the 30% of the time they are men. So if the random number is less than or equal to 0.3, which means random number is between 0 to 0.3, then they are men, right? What should I do next?
Assign a processing time?
Before we get to the processing time, I'm still at the start. The simulation still does not know they are a man. I have given them the tag of customer type, but the initial value for the attribute of customer type or any attribute is always 0. So all the customers, all the entities that come to the system get that tag of customer type, but the value of this tag is 0 for everyone. So first I have to tell the model that, okay, no, this is a man, this is a woman, and this is a child. So first I have to give them the right tag value, right? So then if this random number is in the first 30%, I have to first give them the right tag value. And what is the tag value that we define? It's customer type, okay? Customer type. And I have decided that for men, I assign the value of 1. This is just a decision. Okay, for men, I assign the tag value of 1. Else. Okay, else. So if the tag value is not less than 0.3, that means they're not in 30% in this 30% that are men, then they are in maybe another 50% that they are women, okay? So then I want to say if the tag value, okay, let me write it and then I'll ask you one. So I want to say, okay, if the tag value is between 0.3 and 0.8, then do something, okay? So I say if the tag value, if the tag value is not less than 3, is not in that 30%, if it's not in that 30%, it may be in the next 50%, okay? And if it's in the next 50%, then the tag value can vary between 0.3 to 0.8. There is 50% of that total percentage between 0.3 to 0.8. So with 50% chance or 50% of the customers then can get the tag value of 2 to show that they are women, okay? So that's why here I wrote the condition here that, okay, if the tag is not less than 0.3, then look at this. If it's between 0.3 and 0.8, then they are women, okay? So in that scenario, then, sorry, here also don't forget to put if, else, if, here, else, if the tag value is between 0.3 and 0.8, then do what? Then the tag, customer type,
equals 2.
it takes the value of 2, okay? Else, what is the value of the tag? Should I, first of all, should I specify else if the random number is greater than 0.8?
No,
Because?
because it's if it doesn't fulfill the other two, it's going to just do the else.
Exactly. If I'm already at the else in the code, that means I'm already not anywhere in these two sections. I'm not less than 0.3, I'm not less than 0.8. So then I'm here, then I'm great, then I'm between 0.8 and 1, and that's the other 20% of this whole pie of 100%. So then I'm in the other 20%, and these are children. So if you're not in any one of these two, then you automatically are in the next one. And then I have to give you the tag of 3. Okay. Now, I also want to ask a question. Here in this line, when I say if the random number is between 0.3 and 0.8, do you agree that I can just remove the 0.3 part and just say, check the random number. If it's less than 0.8, then give the tag of 2?
No.
Because?
Well, it's going to conflict with customer type 1.
Okay. When would the code get to this part? When would I get to this part?
It'll only get to that part if it's greater than 0.3.
Exactly. The code will get to this line if I'm already greater than 0.3. If the random number is generated and is less than 0.3, these 2 lines are executed and I'm out of this if loop. I'm done. I will get to this line only if the random number that has been generated is greater than 0.3. So it is already greater than 0.3. I don't need to write it again. Okay, so I can just remove that 0.3 and just say, okay, if the random number is less than 0.3, do this. Else, okay, when I'm coming to else, this means random number is not less than 0.3. Then it's greater than 0.3 for sure. Okay, I know that part. Then just check if it's less than 0.8, that means it's in that 50% of the pie. Then give the customer type, give the tag of 2, else, again, for the same reason. If I ever come to this part of the code, that means the previous parts are not true. So that means the random number is not less than 0.8. So it's definitely greater than 0.8. And then I just need to give the tag of 3. Okay, now before I continue, I also want to ask you something which is more related to writing this code. Okay, so this is the code that I wrote. Still 30% are women, 30% are men, 50% are women, and the other 20% are children. I want to write this code in a different way, and I want you to tell me if that's correct or not and why. So I say, okay, generate a random number. If the random number is in 50%, then give the customer type 2. 2, that's the one we recorded for women, right? I still use the same codes. 1 is for men, 2 is for women, 3 is for children. I just want to write the code a little different and see if you guys are okay with this modification and why. So if random number is less than 0.5, they are women, give them a code of 2, else if the random number is less than 0.7, then give them code 3 because they are children. Otherwise, give them the code of 1 because they are men. Can you tell me if this second method that I wrote this code gives me the same thing that the one on the left side gave me? Can you tell that both of them assign code 1, which is men, to 30% of the customer, assign code 2, which stands for women, to 50% of the customers, and assign code 3, which is for children, to 20% of the customers? Can you confirm that this will be accomplished no matter which code I use? When I generate a random number, I look at it. If it's less than 0.5, which means 50% of that 100% pie. 50% of it is allocated to women. And then if the random number is greater than this and less than 0.7, which is another 20%. So, and then if the random number is between 0.5 and 0.7, which gives me 20% of the pie, then I give the code of 3, which is for children, like here. And else, if the random number is not less than 0.7, the random number is greater than 0.7, and obviously the maximum is 1. So that gives me the other 30% of the pie, for which I'm going to give a code of the tag of 1, which stands for men. So 30% of the pie, or 30% of the time, I'm going to give the tag of 1. 20% of the time, between 0.5 and 0.7, 20% of the time, or 20% of the pie, will get a tag of 3 to stand for children, and 50% of the pie, or 50% of the time, I'm going to give the tag of 2 to stand for women. And the same happens here. So it doesn't matter if you get the first 30% and second 50% and the last 20%, it doesn't matter. As long as of that pie, of that 100% pie, of that 0 to 1 random number that has been generated, 30% of it is for men, 50% of it is for women, and 20% of it is for children. That's all that matters. That will take care of the whole process, that these tag values are assigned based on 30%, 50%, 20% chance for men, women, and children. Okay, everyone is good so far? And we can also here compile. Press compile here. Compile successfully. So if you have anything wrong here, you get an error. The customers go to the barber, and then right here at the barber, what do I need to do here with the barber?
Set ifs for each customer type?
Exactly, because here we said different customer types have different processing time. Okay, depending on if the customer is men, women, or children, they have different processing time. We don't have one processing time for every type of customers. So now when they come to the barber, I want to look at the value of their tag, and depending on the value of their tag, I want to assign the right processing time. okay? So I'm going to get rid of wait thing that I already have because the wait time is different depending on the type of customer. So then I'm going to write another if then else condition. I'm going to say, okay, if, now I'm going to look at the tag value. How do I, what did I save the tag value to in? I saved it in the customer type attribute. Then I look at the tag value and say, okay, if customer type is 1, then do what? Then wait U10 for men, U10, that's the processing time. And customer type 1, we decided that for men, we give them the tag of 1, right? U10, else if the tag is 2, that means they are women. Then wait 12.3, else. Do I need to say if the tag is 3 or can I just say else wait this much?
You can just say else. You don't need to specify.
Why I don't need to specify if the tag is 3?
Because you've already covered all the other bases, so all that's left is 3.
Yeah, exactly. So if I'm ever at this part of the code, then that means the tag is not 1 and it's not 2, so it's automatically 3. So I don't need to say if the tag is 3, but if I'm in that part of the code, the tag is 3, okay? And the tag 3 for children, the processing time is 8 and 2. So wait this amount of time if they are children.
Professor?
Okay? Yeah.
Do we need a then statement after on line 7?
Yes.
Okay, that's not an issue. Thank you.
Thank you.
Professor.
Yeah.
The first line of code you wrote, if customer type equals 1, then wait U10. Can I just copy that 3 times and say, and then just 1, 2, 3?
You can do that.
Okay. Thank you.
Okay, sure. Okay. Now, a couple of things, guys. I always recommend when you write if then else code, always put this part, the code wait or like here when we assign the value to these tags, I just put them a little inside, okay? So that then when I look at this code, I can see that exactly. This is the if, then if this holds, this condition holds, this is what is going to be performed. And then this is the else corresponding to that if. So I put if and else on the same level, and then everything that should happen, I put a little more inside. And then the same will happen for this if. If, this is the second if, and this is the else associated with that. I tried them to be on the same height, like on the same width, and right below each other. And then for the code that should be performed, I put it a little more inside so that I know, okay, if when the second if is executed, when the second if holds, this is the line of code that is going to be executed, okay? And then this is the line of code that is going to be executed if else holds, okay? So this way, it's always nice, it's always easy to understand what is going on. And again, this is a small model that we have, but in real world, you end up writing lines and lines and lines of code. So always doing these best practices help you to keep your code nice and easy to read. And always make sure to use comments whenever it helps you to just put some comment, or this means that, and so forth. So keep that in mind. And that's it. So now we can also compile the code. It's compiled successfully. And we can now run. So just go, before we run, just go to the arrival, and for the inter-arrival time, this is not a big deal and doesn't make any difference, just to be similar to the book. for the interarrival of the customers, we have a triangular distribution, 9, 10, and 12. Okay, so I'm going to change the interarrival time. So go to the arrival. For the interarrival time of the customer, change it to triangular 9, 10, and 12. And then let's run it one more time let's run it for 100 hours. Okay. So now about 560 customers leave the system. The time waiting in the system is a little less. There are just less and less customers in the system. So the time in the system is about, I don't know, close to 2 hours or so for these customers. Okay. Now, as you can see, the results were generated for the customers. That's my entity. But if you want to know, okay, how many men or women or children came to the system during the simulation time? If you want to look at the work in process or the number of customers that are in the system at any point of time, how many of them are men, women, or children? You can't get any one of those automatically from the simulation because the customer is your only entity. Okay, so now we can go to the code, to the simulation, and see what we can write, what code we can write so that we can collect those statistics for ourselves. Okay, so let's assume I want to collect a couple of things. I want to know, out of these 560 exits that I got, how many of them are men, how many of them are women, how many of them are children. Okay. So let's go back to the simulation. So what do you think I need to do here? What is your suggestion?
Define variables.
Variables for each one.
So I have to define the variables. First, let's go to define the variables. So, and then these are global variables, right? So I'm going to define these variables. I'm going to say number men, number child. Okay, I define these three variables. All of them are integer because I'm just going to increase them by 1. And then I come to the processing. So first of all, if you were in the real world scenario, what would you do? Forget about simulation. Where would you go? Where would you stand to count how many men or women or children leave this system?
So to leave the system?
Yeah, that are done and are leaving the system.
At the end. Like
yeah.
when
Exactly. At the end, you go stand next to the barber. When the barber is done and the guy or the person is leaving, then you look at them, see if they are men, women, or children. Okay. So in the simulation, obviously that happens in the second line. I have to come to this part of the code and just say, okay, if the customer type is 1, then do the processing and then increase the variable that counts number of men that are leaving the system. Okay, could I put the increase before wait? Was that okay? Would that be okay? Could I write it like this?
No, because they'll count them before they're done.
Thank you, guys. Okay, no, because then I count them before I start the haircut. What if I stop the simulation right there? Then I'm over counting, okay? Okay, so this one important, very, very important point, guys. As you can see right now, after if, 2 lines are going to be executed. First is the wait line and then the increase line. 2 lines of the code should be executed after if. When I need to run more than 1 line after if, I have to put them between brackets. Is that what do we call them? Brackets?
Yeah, brackets.
Brackets, yeah. Okay. So yeah, I have when we run more than 1 line of code, I have to put these 2 between brackets. that way the simulation knows that if when the if is run and if the condition holds, then all of these should be executed. Otherwise, the simulation just runs the first one and then gives a bunch of errors. Okay? So if you're running more than one line of the code after if, after else, you have to put them in brackets. So you can use brackets, or the other option instead of brackets is to write begin and end. This is acceptable too. So either put begin end at the start and at the end of those lines of the code, or put open bracket, close bracket. Else, that means the customer type is not 1. Then check. If the customer type is 2, then do the processing, they are women, then increase number women, increase that variable, and again, I have to make sure that I open bracket, close bracket, or just put begin end. Else, that means it's children, do the weight, sorry. And then after the weight, increase number child, that variable. Make sure to save. So compile the code. Okay. Okay, so after I perform the processing, the haircut, then I increase the corresponding variable. Obviously, if it's a man, the code, the simulation will execute these lines of the codes, so I will never end up increasing other variables. Okay, and make sure always when you run more than one line after if and else, put the brackets or begin end.
Professor, can you show the line above that where you define just the processing line, the first processing line?
Okay, sure.
Yeah, that. Thank you.
Sure.
Okay, thank you.
Sure. Let's run it one more time. Where can I go to see how many of the exit are men, women, or children?
Tables, summary, variables.
Variable, summary. And which column I have to look at?
The maximum value.
Maximum value, okay? Not average, not total change, none, maximum value. And you can see that out of this 560, 170 of them are men, about 270 of them are women, and about 120 of them are children. Okay, and obviously that's what we expected. 50% are women, 30% are men, and 20% are children. So we expected more women and men compared to the children. Okay, so we can do that. Any questions so far?
Wouldn't total changes give us the same value because we never decreased since it was only increases?
Yeah, so you get the same number from total change because every time you increase, one person has left the system, right? So total change does give you the value equal to what you want for some scenarios. However, since this is not a meaningful column anyway, I always recommend not to look at that. Always put the total change aside because always there is other meaningful column that can give you what you want. So you don't need to look at total changes. The maximum is the one here that gives you the value that you need, and it's meaningful. It's a maximum. Okay, we are going to increase this variable by 1 every time a customer leaves the system. So at the end, the maximum value gives me the total customers that have left the system. Okay, perfect. So pick that column. Okay. Any other question, guys? Okay, let's go back to the model, and now I want you guys to calculate for me the working process for men, women, and children. What is the first step, which is obvious?
You can
And
count
make
how
three
many
variables.
people come in and of each type.
Okay, so before we get into that, first we have to define 3 variables, right? Let's call them men work in process, women work in process, and child work in process. Okay, so these are the 3 variables I have. Okay, so let's do it one by one. I want to calculate work in process for men. Tell me exactly where I have to go to increase or decrease that variable.
Waiting area. After the customer type equals 1, you put increase WIP of 1.
Below that, yeah, no, line A.
Okay.
I usually have to put your curly brackets, right?
I do. Okay, so I go to the first line. I'm looking at work in process. So as soon as these people come to the system, and I know they are men, women, or children, I need to start counting them because they are in the system. I'm looking at work in process. They have come to the system. They are in the system. So then I start increasing men work in process. Okay. Then right here, since if the random number is less than 0.3, okay, I give them tag of 1. That means they're men. And I'm going to increase the work in process, which is counting how many men are in the system. So right here, also I have to open and close the bracket so that the simulation knows both these lines should be executed after if, otherwise I get error. How do I take care of the work in process for women? I come to the next line. If the random variable is less than 0.8, which means they are in that 50% of the pie, then I give the tag of 2 and I increase woman work in process. I make sure to put the bracket as well. And else, they are children, they are given the tag of 3, and I increase the random variable that counts number of work in process for children. What else I need to do with this variable? Is that
decrease WIP when they leave?
We have to decrease this variable when they leave. So after they are done with the barber, after the wait time is over in the second line, when they are done with the barber, the wait is over, then I'm going to decrease the work in process for men. I'm going to decrease the work in process for women. And I'm going to decrease the work in process for children. And I have my curly brackets and everything is fine, so we are good. Let's run. Okay, so if I want to see work in process, I go to variable summary again. Now, which column I have to look at for work in process?
Average.
Average. So 3 men, on average 3.5 men, 5.5 women, and about 2 children are in the shop.
So close to 2.5 men.
Yeah, and at some point we have had even 10 men or 14 women and 8 children waiting in the shop. Okay, so that's my work in process for men, women, children separately. So I can do all these calculations, the number of men or women and children that left the system, the number of men, women, and children that are in the system. I can do all these calculations only because I gave them the attribute. Otherwise, I couldn't. Just because they have the tag, now I can just go and say, okay, if they have this tag, do this thing, do this calculation, and so forth. So just because of that, just because they have these tags, these attributes, I can do all these calculations, extra calculations for you. Okay. Now, let's go to the model one more time. And here, I want you guys to calculate work in process in overall. It doesn't matter if they are men, women, or children. Number of customers in the system, work in process overall. So first, obviously, we are going to define a variable, work in process, and tell me where you have to increase or decrease the variable.
Line 1.
Okay. Why here and not inside the if then else?
It's so it doesn't look at the other code, so it doesn't care what's happening after it. It just sees a person come in and increases that number.
Yeah. So I have to increase it in the if then else if I care about them being a man or women or children. But here I just want to calculate working process overall, no matter if they are men, women, or children, just what is number of customers in the system. That's all that I care about. So I can just increase it right at the start or even after the real, or even at the very end when I'm done with everything. I can just write it here, increase working process. It doesn't matter. It's fine. The if then else, the tag thing is done. That all of that is done. Then the simulation is going to just run one more line of the code and increase this variable for me. It doesn't need to be inside if then else statement. You could do that as well. You could just come here and say that, okay, you could come here to the code and just say, okay, if they are men, increase working process. If they are men or women or children, no, increase this variable. All of that is correct. What is the disadvantage of this method?
Takes more time.
Yeah, why I should write this line 3 times? Why? I already did, but why? This is just a lot of work, right? You can just write it once and be done with it. You don't need to increase it if they are men or women or children. Yeah, it's correct, but it's not smart. So I'm just going to increase this variable at the start or at the very end, and that's it. And I'm done with increasing this variable. How about decreasing this variable? Then to be able to decrease it, I can just come at the very end and just say, okay, decrease work in process for me. When the customer is done, then decrease the work in process. Or I could write it in the code and just say, oh, if the customer is man, then process it, then decrease work in process. And I could write it for men and women and children. But again, why I should repeat this line of the code 3 times? If I want to decrease work in process and I don't care if they are men, women, or children, so I just write decrease work in process. I don't care if they are men, women, or children. And that takes care of everything for me. Now, a question that I have for you. Is this correct if I decrease work in process here?
No, because they haven't gone through the waiting for their actual haircut yet.
Exactly, because they haven't done the haircut yet. So I have to do the haircut, then decrease the work in process. Okay. Let's run that one more time. Now I have the work in process for the customers total. And I also have work in process for each one of them. I have the total, I have the exit for each one of them. I have the total exit for the customers and so forth.